Hello everyone. So now I will present to you my final project in calculus that is composed of 5 problems and it is based on the books that were buy online. Presented to you by yours truly, Ricky Lareza. The problem number 1. Find the first derivative of y is equal to 2 sine squared quantity of 3x squared minus 3. So in this equation, we will use the chain rule d over dx quantity of g of x, quantity of f g of x is equal to f prime g of x times g prime of x. The f here is the 2 sine squared and then the g of x is the quantity of 3x squared minus 3. So to find the first derivative of this equation, we will derive the f and then copy the g of x times the derivative of g of x. So y prime is equal to 2 quantity of 2, copy the sign, and then 3x squared minus 3, then the derivative of sine is cosine, then copy the quantity of 3x squared minus 3 times the derivative of 3x squared minus 3 is 6x, and then simplify. 2 times 2 is 4, then copy, then 6 times 4 is 24x. So, our first derivative of 2 sine squared quantity of 3x squared minus 3 is 24x sine quantity of 3x squared minus 3 and cosine 3x squared minus 3. The second problem. What is the derivative with respect to x of quantity x plus 1 raised to the power of 3 minus x cubed? So in this equation, we will use the sum and difference rule, and also we will apply the power rule d over dx quantity of x raised to the power of n is equal to n x raised to the power of n minus 1. So, to solve this problem, y prime is equal to 3 quantity of x plus 1 raised to the power of 2 minus 3x squared. Since we will find the derivative with respect to x, so we will simplify the quantity of x plus 1 raised to the power of 2. We will have 3 y prime is equal to 3 quantity of x squared plus 2x plus 1 minus 3x squared. And then multiply the 3. So we have 3x squared plus 6x plus 3 minus 3x squared. So cancel the similar term, the 3x squared minus 3x squared. So we will have the derivative with respect to x, dy prime is equal to 6x plus 3. The problem number 3. What is the limit of x cubed plus 2x squared minus 3 over 1 minus x squared as x approaches to 1? So in this equation, if we put 1 into x, by this equation, we will come up with 0. When the limit takes the form of 0 over 0, use the L'Hospital's rules that is solved for the derivative of the numerator and denominator. So to find our limit x approaches to 1, first we will derive the denominator and numerator and then substitute 1 into x to find our limit. So first, derive the x cubed plus 2x squared. So we have 3x squared plus 4x, then copy the constant negative 3 over 1 minus x squared. And then proceed to the derivative of both numerator and denominator. So the derivative of 3x squared plus 4x minus 3 is 6x plus 4. And then the derivative of 1 minus x squared is minus 2x. Next is substitute 1 into x. So we have 6 quantity of 1 plus 4 over negative 2 quantity of 1. And then simplify. So we have 10 over negative 2. And then we will divide it. So our limit of x cubed plus 2x squared minus 3 over 1 minus x squared as x approaches to 1 is equal to negative 5. The problem number 4. Find the dy over dx by implicit differentiation at the point of 0 and negative 2 if x cubed minus xy plus y squared is equal to 4. So in this equation, we will take the derivative of both sides of the equation, then rewrite the dy over dx so that all terms containing dy over dx are on the left side and all the terms that do not contain dy over dx are on the right side, and factor out dy over dx on the left side. So, solution, we have d over the derivative of x cubed minus the derivative of xy plus the derivative of y squared, and then copy the dy over dx since it is composed of y, and then equals the derivative of 4. The derivative of x cubed is 3x squared minus the derivative of xy is y plus x, then copy the dy over dx using the product rule. Then the derivative of y squared is 2y, then copy the dy over dx. And the derivative of 4 is 0 since it is constant. So, 3x squared minus y plus x dy over dx plus 2y dy over dx is equal to 0. Put dy over dx because according to its meaning, we write dy over dx to all terms containing that it is derived. So factor out dy over dx and then transpose the non-dy over dx on the right side. So quantity of x plus 2y dy over dx is equal to negative 3x squared plus y, and then divide both sides by x plus 2y. So our dy over dx is equal to negative 3x squared plus y over x plus 2y. Since there is a point of 0 and negative 2, we will substitute the 0 and negative 2 to the x and y. So we have negative 3 quantity of 0 squared plus negative 2 over 0 plus 2 quantity of negative 2. So that will be negative 2 over negative 4. So our dy over dx is 1/2 because we will divide 2 and 4 and then cancel the negative sign. So our dy over dx is 1/2. The fifth and the last problem. Find the derivative using delta method. Y is equal to 4x squared minus 3x minus 1. In this equation, The delta notation or the delta method is another way to solve or derive the given equation. Our formula to derive using delta method is limit delta x approaches to 0 f quantity of x plus delta x minus f of x over delta x. Our f here is the constant number and our x is the quantity of x plus delta x depending on their power. So the limit delta x approaches to 0 for quantity of x plus delta x squared minus 3 quantity of 3 plus delta x minus 1, and then copy the f of x, which is the y, minus quantity of 4x squared minus 3 minus 1. And then we will simplify. So we have limit delta x approaches to 0 for quantity of x squared plus 2x delta x plus delta x squared minus 3x minus 3 delta x minus 1. Then simplify the negative to the f of x. So we have negative 4x squared plus 3x plus 1 over delta x. And then we will multiply the 4 to its component. So we have 4x squared plus 8x delta x plus 4 delta x squared minus 3x minus 3 delta x minus 1 minus 4x squared plus 3x plus 1. So we will use the cancellation form. So our limit as delta x approaches to 0 is 8x delta x plus 4x squared minus 3x over delta x. And then we will factor form our numerator to cancel our denominator. So the limit delta x approaches to 0, delta x quantity of 8x plus 4 delta x minus 3 over delta x. So cancel delta x. So our limit delta x approaches to 0 is 8x plus 4 delta x minus 3. Then substitute 0 to delta x. So 8x plus 4 quantity of 0 minus 3. So our final answer is 8x minus 3. So our answer for the derivative using the delta method of y is equal to 4x squared minus 3 minus 1 is equal to 8x plus 3. That's all. Thank you for listening.